Armageddon gets one big thing exactly right, and almost everything else backwards. The threat is real. The timeline is what saves you, not the heroics. Start with the headline claim. A Texas-sized asteroid, found only 18 days before impact. That makes great cinema and terrible astronomy. Something hundreds or even 1,000 kilometers across reflects a lot of sunlight. It would stand out far away as a major object in the inner solar system. You can hide smaller, darker rocks until late, especially if they come from near the sun. But those are local or regional hazards, not extinction-class monsters. The movie wants the biggest possible danger and the shortest possible warning. Those two goals collide. Then there is the core plan. Drill an 800-foot shaft, drop in a nuclear bomb, split the asteroid in two, and watch both halves miss Earth. The real obstacle is not whether nuclear weapons can crack rock. It is whether you can give the fragments enough sideways speed, in the little time left, to actually miss the planet. If you act years in advance, a small nudge becomes a big miss. If you act days in advance, you need an enormous lateral push. Scale makes the problem explode. If Texas-sized means roughly 1,000 kilometers across, you are not talking about a typical near-Earth asteroid. You are talking about a small world-class body, bigger than the impactor linked to Chicxulub. At that size, the asteroid's mass is so huge that the energy needed to split it neatly and then fling both halves aside blows past the movie's quarry blast logic. Even worse, fragmentation is not the same thing as deflection. Deflection means changing the orbit so the object misses Earth. Disruption means breaking it up. Late disruption can turn one predictable impact into many less predictable impacts. Real breakups tend to make a spray of pieces, not two clean halves. If those pieces are still on Earth-crossing paths, you may have created a shotgun blast. Modern planetary defense thinking leans the other way. Earlier is better. Small changes, applied early, compound into safety. NASA's DART mission demonstrated the key idea. It wasn't crude, and it didn't use nukes. It slammed into a small asteroid moonlet to measure how much a kinetic hit can shift an orbit. That is the less cinematic lesson Armageddon accidentally teaches. You do not want a last-second miracle. You want time, measurement, and planning. The movie also treats the mission like a fast, improvisable road trip. 2 experimental spacecraft launch, rendezvous, land, drill, and escape. Each ingredient has a real-world cousin. Put together on that schedule, it becomes orbital mechanics fantasy. Deep space missions are dominated by preparation. Trajectories are not eyeballed. Rendezvous is not pull up alongside. An incoming impactor is moving at kilometers per second relative to Earth. Intercepting it is a high-energy, precision geometry problem. Landing is also misunderstood. Small body operations are weird. Low gravity means you can bounce off the surface. Anchoring becomes the hard part. Dust does not settle the way you expect. Drilling torque can spin your whole vehicle instead of turning the bit, unless you are firmly attached. Armageddon's drilling looks like terrestrial heavy industry. In reality, the physics fights you. That connects to another subtle point the film gets wrong, while still raising a great question. Asteroids are not uniform. Some are solidish. Many are fractured, porous, or rubble piles held together weakly by gravity. Their surfaces can be boulders, fine regolith, or both, and their interiors can be a mess. You don't truly know how to interact with a target until you have characterized it up close. Armageddon's NASA has no time for that, yet it commits to deep drilling as if the asteroid were a predictable block of rock. The film's Asteroid also changes behavior scene to scene. Sometimes it has enough gravity for people to walk and drive like they're on a mountain. Other times, things float and leap away. A truly 1,000-kilometer body would have meaningful gravity and would tend toward a more rounded shape. If it's small enough to be jagged and chaotic, then the Texas-sized extinction claim falls apart. The visuals are spectacular. The physics refuses to pick one consistent regime. Yet the movie lands a few important truths. Impact risk is real, and it is civilization scale. The right goal is to make the object miss Earth, not to evacuate the impact zone. And the response would be institutional, not just heroic. You would need surveys, orbit refinement, and coordinated communication.